this yourself. Pretty good question. Okay beta, it says the following. Consider the mapping F from set of natural numbers m to set of integers. So I am going from natural numbers to integers. And the function is defined in two ways. One, the function is defined as n minus 1 by 2. When is this defined beta? When it is odd. And it is defined as minus n by 2. When is this defined beta? When it is even. So function has two parts to it. One when it is odd and second when it is even. I have defined the function like that. You have to go ahead and tell me whether it is 1 to 1 or not, whether it is onto or not, whether it is both, whether it is either. Take some time. This is a tricky one. Try to solve this yourself. Then I will discuss this with you. Take a moment. Write your answers in the chat section. Okay. Let's start. I am going to take the first case, and that case is going to be that, okay, first of all, just try to think about it. First of all, I need to ask if it is 1 to 1 or not. Just think about this. The function, the way that I have defined the function, it says that if you put anything odd in n, you will get a corresponding value attached to it. Anything odd. Like I put n as 1. Then I will get 1 minus 1 by 2. That means I will get 0. When I put n as 3, I will get 3 minus 1 by 2. 2 by 2, that means 1. I put different n's and I will get different functional values attached to it. This is when I am showing when n is odd. Same try for even. I put n as 2, but I will get 2 by 2, which means minus 1. I put n as 4. I get 4 by 2, minus 4 by 2, which means minus 2. So I put different values of n and I am getting different answers. This should hint you something. Now let's see this proof. So I am saying let n1 and n2 be two numbers such that they are odd numbers. Then what can I go ahead and do? Ma'am, let me go ahead and see what happens if I try to equate f of n1 to f of n2. The rule is that if f of n1 equal to f of n2 implies n1 equal to n2, then ma'am it is a one-to-one function. Right? So if the functional values are same and it gives me that those x's were same, the numbers I plugged in were same, it will be a one-to-one function. So just think about this. Ek aur example leke dekhte hain before I go ahead. All of you should be aware about this, the mod function. What is my mod function? Mod function looks like this. Here I have two n's, n1, n2, and they give me the same value of the function. One value of function attached to two different values of n, it's not a one-to-one function. A one-to-one function means if the functional value is same, it should imply that my n1 and n2 should also be the same. Let's try this here. So if I try this when my n is odd, so when my n's are odd beta, then what do I get? I will use the function n minus 1 by 2 na. So I took n1 minus 1 by 2 is equal to n2 minus 1 by 2. When you solve this, you will get n1 minus 1 is equal to n2 minus 1. This implies n1 is equal to n2. So I started by equating the function and I got that n1 and n2 are equal to each other. It means it is a one-to-one function. Try it for the even values also. Try it for the even values also. So for even value, what is your function beta? The function is minus n by 2. Let n1 and n2 be both even. So if minus n1 by 2 is equal to minus n2 by 2, so beta 2 and 2 cancels out. Minus minus cancels out. It means n1 is equal to n2. So when my function are equal, I am getting that these numbers are also equal. That means it is a one-to-one function, whether it is even or odd. So we have proved that it is a one-to-one function. Homework for you. You will prove this. That is why I haven't written anything here. You will go ahead and prove to me that it is also an onto function. So it will both be a one-to-one and onto function, and therefore all of you who are saying that the correct answer should be C are correct, that it is both one-to-one and onto. A very good tricky question. Why? Because in this beta we have two parts given to us. Just a hint for you for onto. Beta f is a function that goes from n to z. Just try to think about this. Okay, I am leaving that to you. Okay, beta, next question. I am giving you a moment. Try to solve this on your own. It says, which of the following is not a bounded sequence? I am waiting for your answer. Try to solve this. It is not bounded, huh? The options given are 1 by n, 1 by n square, 1 by n to the power 3 minus 1 to the power n into n. Which of the following is not a bounded sequence? Try to solve this. Okay, beta? Okay, you're saying B. Let's see. Let me take this with you together. So look at the D part. You're right. But look, simply try to use method of elimination sometimes. Huh? So look here. Minus 1 to the power n into n. Put n is equal to 1. What will you get? Minus 1 to the power 1 into 1. What will you get, beta? Minus 1 into 1 minus 1. That's the first element. Put n is equal to 2. What will you get? Minus 1 to the power 2 into 2. So 1 into 2, so 2. Second element. Put n as 3. Minus 1 to the power 3 into 3 minus 3. So you see that there is no bound. How is your sequence going? If I were to show this graphically, very simple. The numbers I have here, they go, I have minus 1, so minus 1, and then I have plus 2, and then I have minus 3, and then I have plus 4. So you see that this is exploding series. Minus 1 plus 2, minus 3 plus 4. So it will keep going like this. It will become bigger and bigger and bigger. Here also, in the lower part also, and in the upper part also. There will be no bound to it. Right? So, because there will be no bound to it, therefore it will be an unbounded sequence. So everyone who said that the answer should be D, you are correct. The correct answer to this question should be D. And that's absolutely correct. Okay, come to the next question. Oh, we are done with the questions, is it? Good. So we have completed all the 5 questions for today. And I hope that you find these questions useful. These are some of the good questions I could pick up from sequence and series. And tomorrow I will go ahead and meet you again with yet another series and yet another set of questions. Till then, again a reminder to all the students. So if you want access to these questions at any point of time, you can go to the website ArthaPoint. You can click on this series, and under this series you shall be able to go ahead and find a list of all the series that we have started. So this is our first series, which is Yakeen series for ISI, second series which is Sambhav series, and third series which is Sankalp series. Another announcement that I have before we end, We have already started receiving enrollments for the mock test, which is there in December. So the first mock test of ISI, full 3 hours, computer based in the actual environment, actual mock test, it starts from 2nd of December. We will have 10 IIT mock tests, my bad, I said ISI. We will have 10 IIT JAM mock tests and 5 GATE Economics mock tests. And all these 15 mock tests, beta, you will get recorded answer solutions to those, right? So imagine that one paper of IIT has 60 questions. So 60 into 10, 600 recorded solutions of IIT, and similarly for GATE also you're going to get those solutions. And apart from that, whoever is enrolling for the mock test series will also get the past year solutions of both IIT and GATE. For students who are part of our course already, who are part of our MA Economics course or IIT course or GATE course, you already will get access to it. You don't have to pay anything. Please don't come up with queries saying, ma'am, do we have to pay anything additional? No, everything is inclusive in your course. But for people who are not a part of the course and who want to go ahead and enroll for the mock test series, the admission is open. You can go ahead and enroll in beta. I will soon be launching the date sheet for it, and the exams will be conducted on those dates. If you miss the exam on that day, it will be available for you to be given later on. But date sheet just brings discipline, and it just ensures that you sit in that time and do the test. Okay, thank you everyone.